Hello, I'm Professor Von Schmohawk, and welcome to YU. In the previous lecture, we saw that exponentiation is shorthand for repeated multiplication. Any number a raised to the nth power is equivalent to multiplying n a's together. In an exponential expression, n is called the exponent and a is called the base. We also saw that to multiply exponential expressions with the same base, we add their exponents. And to divide exponential expressions with the same base, we subtract their exponents. We can use these rules to find out what an exponent of 1 would mean. If we start with a non-zero number, a cubed, and divide it by the same number, squared, we subtract the exponents, and the result is a with an exponent of 1. We know that a number cubed is equivalent to 3 copies of that number multiplied together, and a number squared is equivalent to 2 copies multiplied. We can simplify this fraction by canceling out 2 copies of the number in the numerator and 2 copies in the denominator, which leaves us with 1 copy of the number. So any number raised to the first power is the same as the number itself. To find out what an exponent of 0 would mean, let's divide a to the first power by itself. Subtracting the exponents, we get a with an exponent of 0. Of course, any fraction where the numerator and denominator are the same is equal to 1. So we see that any number with a 0 exponent is equal to 1. There is one caveat to be aware of. What if a is 0? We showed that a raised to the 0 power is 1. So you would think that 0 raised to the 0 power should be 1. The problem is that no matter how many times we multiply 0 times itself, we always get 0. So is 0 to the 0 power 1 or 0? The answer is that it is undefined. So far, we have seen the meaning of integer exponents of 0 or greater. But is there any meaning to a negative exponent? Once again, we can use the rules of exponents to determine the meaning of raising a number to a negative power. If we take a non-zero number, a, raised to the 0 power, and divide it by the same number raised to any positive power, n, we subtract the exponents, so the result will have an exponent of negative n. Since a to the 0 power is equal to 1, this tells us that any number with a negative exponent is equivalent to 1 over that number with the same positive exponent. For example, a to the negative third power is equal to 1 over a cubed, or 1 over a times a times a. The only number that cannot have a negative exponent is 0, since this would be the same as 1 over 0. And dividing by 0 is meaningless. So now we know the meaning of any integer exponent, and the rules of adding and subtracting exponents work in every case. In our next lecture, we will see how exponents play a big role in our decimal number system and how they are used to create what is called scientific notation.